Why do you stream you're studying? Alright, let me... Oh, by the way, hey! What's up, chat? Starting... I should really start these streams earlier. I'm starting at 9 in the morning. I should really start at like 8 to save an hour of my time. But, we'll do better next time. Thank you, Space, for the gifted. Early gift for those who are early. Oh god. Alright, let me make one thing clear, alright? I feel like people are kind of misunderstanding why I'm doing these study streams. I'm not studying for some big exam I'm doing. I already graduated high school a while back. I have like a long gap between my high school year and my first year of college. So I have a lot of extra time in my hands. So why not let's just study some stuff, you know, advanced study, get some, you know, so we don't feel behind when school starts eventually. That's why we're doing this. It's not, we're going for the long run here. And we're doing pre-calc because we gotta make sure, you know, we learn everything. Because even my high school year, when we learned pre-calc, we did not learn about law sign, we did not learn about the addition, you know, trig identity, so we did not learn like half the stuff there. So it is what it is, you know. Make sure we get to the calc class, the calculator class eventually, so that, you know, it's also for the long term, right? Because if I know the topics in advance, that means less time for me to study, which means more time for me to work on videos while I'm in college. So, you know, yeah, put that into perspective. That's the smart thing. And as always, before we study, you know, it's always good to to have some kind of humor before we start the stream, because there's definitely some weird shit going on. But let me show you guys what's going on. Let me get my chat on my phone. We'll play Balatro multiplayer. I actually did have like a week-long Balatro phase. I was like that's all I was playing, but like I got bored of it eventually. And then Yahya Mais, he does like 10 he has like 10 videos on freaking Balatro. Is it really that good? Like for me, it's like it's like it's dopamine for like a week or two, and then it's like it gets old. I don't know, man. Or it becomes a headache to try and remember everything. Anyways, let's start. So, the thing we gotta start with is I found this tweet like 10 minutes ago, and it said that YouTube dropped its top content creator list for 2025. Oh boy. I need to remove this because I'm on another tab, so... Hey, get rid of this. There you go, thank you. YouTube's top 10 creators. Oh boy. Alright, trending topics, Squid Game. Is this 2025? What? Ain't no way 2025. Squid Game is number 1 still? That's probably because of all the brain rot content, right? Did Unk made it? Maybe. User-generated Roblox. Oh wait, no. It's not numbered. It's just like, okay. Because these ones have numbers. These ones don't. User-generated Roblox experiences. Look at this. Even they know that Roblox is not a game. How does YouTube know more about Roblox than Roblox themselves? Anyways, Grow a Garden. Fuck you. Danny's World. What is that? Forsaken. Mid-game. And Steal a Brain Rot. Shit. I will always be a Forsaken hater, bro. It's like the most mid-gaming experience in the world. I cannot. K-pop Demon Hunters, duh. Brain Rot. Charlie Kirk! We are Charlie Kirk, we carry the flame. La Boo Boo, okay. Switch 2, alright. Cookie Run Kingdom. I didn't know the fandom was that big. Blue Lock, alright. And Cat's Eye, duh. One day, if I become a big enough fan of Cat's Eye, y'all gotta see that video one day about falling into girl groups and stuff. But I'm not actually. I'm not that big of a fan. Just see them on Twitter like every like day or two. Anyways, top creators: Mr. Beast, duh. Kalis Blocks. That's an industry plant right there. I show Speed. No, 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 no. Speed should be at that number 2 spot. Speed should be number 2. Who is this industry plant number 2? Put him like, get him out of here. Speed should be number 2. On God. Double Date. Okay, well I don't know them. Cadell and Mia. Who are they? Charlie. Why is YouTube celebrating Charlie Kirk? Bro, is he an industry plant also because he got them? Is it because he got shot? Is that why he's on here? I swear he's not that big compared to like everyone else on here. Is he really that big? Or is he just here because he got freaking assassinated? Is that the reason? The guy was like, oh, this was a mistake. Islam is not compatible with Western society. And then, even if you agree with everything Charlie Kirk says, you cannot agree that he's a good arguer. With all that said, I don't like the way he argues with people. It's not in good faith. But it's out of context, and the students are doing it optionally. Doesn't matter if it's optional. A debate's a debate nonetheless. It's out of context. What context could there possibly be for someone to say the shit he said? Anyways, Law by Mike, okay. Corey Kenshin, hey, that's a pull right there. That's a pull. Hey, I'm not gonna lie, Corey Kenshin should be like number 5 or number 4, bro. On God, like he deserves more love. Put him on here. But I'm very happy Corey Kenshin's on here. Zach D Films, okay. Okay, makes sense. And Outdoor Boys. How is Outdoor Boys only at number 10? Really? Like, no disrespect to Corey Kenshin, but like, how is Outdoor Boys below him? I feel like he should at least be in that 4 spot, Corey at that 5 spot. And then like some random person I don't know, number 3, Speed number 2. Zach D Films number 1. Top podcast, Joe Rogan. Bro, Joe Rogan. Alright, bro. I'm not Professor Dave, so I'm not gonna say anything about that. Kill Tony. I don't know any of these podcasts. Okay. Red and Link at number 3. It makes sense. Rotten Mango. What's that? Midas Touch podcast. What is that? Smosh reads Reddit stories at number 8. Okay, I'm happy Smosh is here, but number 8? And you're just reading Reddit stories. Anyway, alright. Top songs on shorts. Forrest Frank, Your Way's Better. What? What? Joyful Chest. I know this song. It's a good song. Anxiety. Alright. Pretty Little Baby, Jesus Christ. What? Skrilla Doot 67? You got Saja Boys, okay, duh. Billie Eilish, alright. Top songs, period. You got Die With A Smile, Apata, K-pop, Demon Hunter, K-pop, Demon Hunters, K-pop, Demon Hunters. I mean, it makes sense that there's 4 K-pop Demon Hunter songs. I mean, it's just a big movie, man. It's a good movie. I don't know what to tell you. Ordinary, Luther. Oh my fucking god, it's this. It's the freaking mustard song, isn't it? But wait, where is We Are Charlie Kirk? Yeah, you're right. Yeah, whoever said that in chat, you're very right. Where is Charlie Kirk's song? Where is that? It makes no sense. He should be a number. Hey, no bias. We Are Charlie Kirk should be like at number 8 spot right there. But alright, there. Alright, we have finished the preliminaries because we just wanted to, understand how that works. But now we're gonna get to the actual study. Can someone explain K-pop Demon? I'm still stuck on the Minecraft movie. Gee, damn. All right. So yesterday we learned about we finally mastered the trig, word problems. Right? We have to get the limit, not the we're not there yet. The maximum, and the minimum. We have to shape the actual wave, and then we remember that there's two equations to solving for x in a trig equation, right? Because there's one, if it's cosine, right? Cosine of an angle is equal to cosine of a negative angle. If it's sine of an angle is equal to sine of pi minus the angle. So, you gotta search for two answers, and yeah. Oh, mastered. Hey, this is close enough. All right, this is close enough. I don't want to be stuck on the same thing for like 3 days straight. I mean, if you want to. hey, man. I don't know what to tell you. Let me try this one. I only got like 2 right. All right, he solved. Kong tried to solve the following equation where x is in degrees to the nearest tenth, but it's from negative 360 to 90, but he made a mistake. Alright. So you have cosine. Oh no. You have cosine x and minus x. What? What is x plus 360? Okay, I mean, duh. Alright. Oh, okay, 360n. Oh, but he didn't go negative. He missed. I think he missed one. Yeah, this one. I bet. Alright. Now, we should get all 4 right. Because, like, we're, like, super good now. So, we have to solve for x. So, we have sine x. That. And x is equal to that. Around this number. But, sine x is equal to x plus 2 pi. We're in radians, right? Okay. Radians, and then from pi to 4 pi. Alright. Wait. Alright, 0.71 radians? Wait, 45 degrees? This one. Alright. From 180 to 720. Alright, do this, and 53. And you got... Okay, x is equal to x plus 360 n. Alright. And you have this. Okay. And then you have the negative value. Plus 360. So from 180 to 720. Oh, but look. The interval's wrong. I have no idea what Diba's doing on the calculator. It's because he didn't watch the other study streams. Arc cosine of cos x is equal to x if x is between negative pi over 2 and pi over 2. Interesting. Kelly tried to solve the following equation where x in radians, the nearest hundredth. It's from pi to 4 pi. Okay. 1.93. Okay. That is a number of radians, alright. Oh, but you missed one. You forgot that this one, the dude forgot that x could be negative also. Forgot these negative values. Oh my god, I was so close. Negative n. Oh, because we're using n, not okay. I was confusing it with the cosine value. So it's probably this one. Okay, come on, bonus question. We gotta redeem ourselves. X in radians. Wait, what? Sine. There's no way this is the same answer, right? Wait, what? In degrees instead of radians? Okay, fine. Let's just assume it's correct then. So sine is equal to x, sine of x plus 2 pi, okay. Sine is equal to sine of negative x. Okay, this is wrong. This one's wrong. Cosine function. What'd I say about mastering again? I didn't hear you. What did I say about mastering again? I don't want to do this, bro. All right, you get the point. We did all this like yesterday. Let me try to remember everything. All right. So yesterday we learned about double angle identity, angle addition, double angle identity, and squared function. So if I can get the paint.net on the top right corner, let me try and write them down. Write them all down. So you have sine. That's way too low. So you have sine A plus B is equal to sine A cos B is equal to sine B cos A. We did not watch a proof. Maybe we should watch. Oh wait, no, wait, not equals. Plus. We did not watch like a proof of this thing, but well, maybe we'll later. And then if you do sine A minus B, I think you guys can see it. Yeah. Sine A minus B is equal to sine A. Sine A cos B minus, see, that's the difference there. Sine B cos A. Literally in school right now, twin. Hey, this is like unironically studying though. So, like, you know, you can watch me on stream. Cosine A plus B is equal to cos A cos B minus sine A sine B. And then you get the point. If it's a minus, if it's a minus, if it's instead of A plus B, if it's A minus B, this will be a plus instead. And then I think there were some others. So sine, I think it was 2A is equal to 2 sine A. Was it sine A cos B? I think. Oh no, wait, no. Sine A sine B. Sorry. Sine A. Fuck. What was it? Sine A cos A. There you go. I was like, what? There's only one angle. Whoops. Cosine 2A is equal to 2 cosine squared A minus 1. Boom. See, I can just remember this stuff in math, bro. I'm just like the best. I'm like the smartest Einstein. I almost said Epstein again. Einsteinish person ever. Although I don't remember the sine squared a. I'm not gonna lie, bro. I don't remember this. And then cosine squared a. Let me search that up. Sine squared x equals identity. You get it right, rearranging the wrong above, yeah. This one, it's derived from these ones. So, this is what it is. Oh, okay, I searched it up. It's 1 minus cosine, what is it? 2x, 2a over 2. Alright, 1 minus over 2. What about cosine? Got people actually helping! Okay. Alright. I remember what Sal Khan, the greedy, amazing person he is. I don't know, I said greedy by accident. I don't mean anything wrong. Right? That was a Freudian slip. I did not mean to say anything. It's so cosine squared is the same thing, except it's a plus instead of a minus. Okay, so I should just remember this one. Cosine is 1 plus cosine 2a over 2. It comes from this. Oh, wait, duh. I mean, you can see it. It just derived from there. Just derived from here. But this one's a bit different. Ah, whatever. You get the point. This is what we learned yesterday. But let's move on from that. Alright, let's see. Let's move on. Let's move on to this one. Find trig values using angle addition identities. Alright, bet. Oh my god! What are we doing here? Bro! Okay. Okay, maybe I should have watched the videos. Fine. I hate you.
What I want to attempt to do in this video is figure out what the sine of 7 pi over 12 is without using a calculator. And so let's...
Oh, sine of 7 pi over 12. I don't know.
Let's visualize 7 pi over 12 on the unit circle. So one side of the angle is going along the positive x-axis.
All right.
And then let's see, if we go straight up, that's pi over 2, which is the same thing as 6 pi over 12. So then we essentially just have another pi over 12 to get right over there. This is the angle that we're talking about. That is 7.
Yeah, because it's a little more than pi over 2, so it's a little over
pi.
90. I have to learn Hindi.
Over 12 radians. And the sine of it, by the unit circle definition of sine, it's the y-coordinate of where this ray intersects the unit circle. So this is a unit circle, has radius 1. Where it intersects the y-coordinate is the sine. So another way to think about it, it's the length of this line right over here. And I encourage you to pause the video right now and try to think about it on your own. See if you can use your powers of trigonometry to figure out what sine of...
Wait, what? Okay. So sine 7 pi over 12. Okay. I don't want to just like have a formula sheet. Let's not do that. So you have a triangle where this is the sine. All right. Okay. And so you have this angle. This is 7 pi over 12, a little over 90 degrees. And this is 1. And this is cosine 7 pi over 12. Do you know any clever way of writing 7 pi over 12? I mean, I know that pi over isn't pi what is pi over 12 anyway? Like 12, 15 degrees? No, I can't think. Okay, pi over 6 is 30. Yeah, 15 degrees. All right, bet. So, this is 75 degrees. So this is sine of this angle. So it's isn't there a thing where like let me think about this real quick. This angle, you have an angle here. Isn't that the same as looking the sine of this angle? Damn. I'm confused as hell. All right, let me figure. I can't figure it out. I don't know.
12 is, or essentially the
I don't know what
length
kind of like delusional magic
magenta line.
he wants me to
So
do.
I'm assuming you've given a go at it. And if you're like me, your first temptation might have been just to focus on this triangle right over here that I kind of drew.
I feel like there's
for
like
you.
another triangle
So
I'm
the
missing here.
triangle
Just
looks
to add
like
something
this.
else.
It looks like this, where that's what you're trying to figure out. This length right over here, sine of 7 pi over 12. We know the length of the hypotenuse is 1. It's a radius of the unit circle. It's a right triangle right over there. And we also know this angle right over here, which is this angle right over here. This gets us 6 pi over 12, and then we have another pi over 12.
I mean, you can just do this as well. Same like this. Nah, I got nothing, bro. I'm just.
Oh, so we know
I'm
that
catching
that
blanks
is
here.
pi over 12, not pi over 16. We know that this angle right over here is pi over 12. And so given this information, we can figure out this, or we can at least relate this side to these other sides using a trig function relative to this angle. This is the adjacent side.
Oh wait, I'm just an
And so-
idiot. I'm just an idiot then. Wait, okay, he gave me something. I mean, you can make a right triangle like this. I was confused though. I feel like it's like if you do like that, I feel like I would want to use this. I would use this as a right. You have this value. Okay, does that mean that complementary angles have the same sine value? So this is pi over 12. This entire thing is 7 pi over 12. This is pi over 12. Let me search it up. Do complementary angles have the same sine? Oh, they don't. The sine of one angle is the cosine. I mean, duh. Cosine. Okay, well. It's easier than the previous topic. I don't know why. I just cannot, like, I don't, my brain is just so stupid when it comes to this shit. Because I don't know how he's getting this right triangle here and I'm solving for this angle. Like, when I think of this angle entirely, maybe it's a different angle here. What about supplementary angles? Okay. Yeah. Okay, remember that sine theta equals sine of pi minus theta. Because these two have supplementary. Alright, that's what I was confused upon. I'm just mixing my lessons like in like a big hoshmosh of goo. So, okay, so we can look for the sine of this angle right here. Where this angle is 7 pi over 12. and this angle is 5 pi over 12. So we can get that this is 5 pi over 12. And we're looking for this value. This is 1. Okay. Looks very tough, actually. True. I got an email. Whirow, you're selected by YouTube. Apply today to the shopping bootcamp. I don't have... You know, YouTube has been emailing me like 8 times about, oh, YouTube shopping, you can tag products, and then if people buy them, you get a commission, and then you can get 10,000 peso bonus. What are you gonna buy from my channel, bro? Oh shit, I'm sorry, I said a bad word. Okay, so remember that this is opposite over adjacent. Or, yeah, opposite over hypotenuse is the sign. So this is 5 pi. This is 12, let's say. Wait, duh. We're looking for the sign of that value. What am I doing? I don't... Alright, I give up. I keep going random directions here.
So the cosine of pi over 12 is going to be this magenta side over 1, or you could just say it's equal to this magenta side. So you could say this is cosine of pi over 12.
What? How's that cosine?
So we just figured
How is that cosine? Oh, because if you look... Okay, fine, whatever.
out that sine of 7 pi over 12 is the same thing as cosine of pi over 12.
You know what, Mr. Salkan? I'm gonna stick to your method. Your method is, like, cleaner than me having to remember the supplementary angles and all that. Your method's definitely clearer. So you go here, and this is pi over 12. And you have to look at it from this way. So this, like this. This is pi over 12. This entire thing is cosine pi over 12. Yeah, pi over 12. Which is also equal to sine 7 pi over 12. You know why? Because it's called cosine. Cosine, co means complementary. So...
But that still doesn't help me. I don't know offhand what the cosine of pi over 12 radians is without using a calculator. So let's...
Pi over 2 is 1/4 of a circle. Pi is half a circle. Yeah, that's what I've been doing.
Instead of thinking about it this way, let's see if we can compose this angle, or if we can decompose it into some angles for which we do know the sine and cosine. And what angles are those? Well, those are the angles in special right triangles. So, for example, we are very familiar with 30, 60, 90 triangles.
Okay, yeah, I know
30,
that.
60, 90 triangles look something like this.
So yeah, pi over 6, pi over 3,
it.
and
if they have, so instead of writing the 30-degree side, I'll write, since we're thinking in radians, I'll write that as pi over 6 radians. The 60-degree side, I'm going to write that as pi over 3 radians.
Pi over
of course,
3,
this is the right
pi
angle.
over 2.
And if the hypotenuse here is 1, then the side opposite the 30-degree side, or the pi over 6 radian side, is going to be half the hypotenuse, which in this case is 1/2. And then the other side that's opposite the 60-degree side, or the pi over 3 radian side, is going to be square root of 3 times the shorter side. So it's going to be square root of 3 over 2. And so we've used these types of triangles in the past to figure...
Okay.
out the sine for 3 radians. And then the other side, that's opposite side, is going to be half the hypotenuse, which in this case is...
The short side is half the hypotenuse. Okay, and it's root 3 over 2.
Or 60, or in this case, pi over 6, or pi over 3. So this, we know about...
Yeah, so they have x here, root 3x, and then 2x.
Pi over 6 and pi over 3. We also know about 45, 45, 90 triangles.
Also, bro, when you draw the trig circle, you can put cosine on the y-axis and sine the x-axis. Yeah, because it's rotated 90 degrees. Because he drew the angle like this. What is this? Sine. Like this. If you flip it, you get like this. And then this thing is going to be sine. This is cosine.
We know that they're isosceles right triangles. They look like this. My best attempt at drawing it.
Maybe I
That
should
one
do
actually doesn't
physics
look that
like
isosceles.
after calc.
Let me make it a little bit more. So I don't know. That looks closer.
Alright,
the hypotenuse are going to be square root of 2 over 2 times
Okay.
it's the same thing as pi over 6, pi over 3, pi over 4. I can use these triangles either using the classic definition, SOHCAHTOA definitions, or I could stick them on the unit circle here to use the unit circle definition of trig functions to figure out what the sine, cosine, or tangent of these angles are. So can I decompose 7 pi over 12 into some combination of pi over 6's, pi over 3's,
Oh, he's seeking to deconstruct it?
or pi over 4's? Well, to think about that, let me rewrite pi over 6, pi over 3, and pi over 4 with a denominator over 12. So let me write that. So pi over 6 is equal to 2
pi over 12, alright. Where's he going with this?
Pi over 4. Let's
Okay.
see. 2 plus 4 is not 7. 2 plus 3 is not...
So he's turning pi over 12 into like two things? So, okay. Pi over 3 is 4 pi over 12. Pi over 4 is 3 pi over 12.
4 plus 3 is 7. So I could use this and this.
Is that really all he did? He just deconstructed 7 pi over 12 into pi plus 3 plus pi plus 4. And then he used the... I see where you're going with this.
4 pi over 12 plus 3 pi over 12 is 7 pi over 12. So I could rewrite...
I'm not gonna lie, Shalkan, you really confused the hell out of me with the freaking unit circle, bro. Like, I was like, where are you going with this?
12?
So you do that, and then you do the thing. You do this, that thing.
Use our angle
Wait, what?
plus, let me do this, plus pi over 3,
Yeah.
plus...
Okay, so you turn 7 pi over 12 into, okay, pi plus 3, pi over 4, plus pi over 3.
Sine. In order to write that,
And then you do this.
And
And then
over 4.
you can just remember, and you can just use your right hand to solve for everything. All right. Okay. So it's equal to that value, which is root 2 plus root 6 over 4. All right. Okay. You can also use the cosine 2a. Wait, what do you it's not a double angle though. Where's the double angle? All right, whatever. Okay, that was something. Okay, that's a way to solve something. All right, nice. Where's my music? Damn.
In this video,
Sine 2a,
we're
alright,
try
bet.
to compute what tangent of
Oh no, we're at tangent. Man, this entire time my brain was like freaking dying for just sine and cosine, and then there's like 4 more. Oh boy.
13 pi over 12 is with
Oh
using
my
a
God.
calculator. But I will give you a few hints. First of all, you can rewrite tangent of 13 pi over 12 as tangent of... Instead of 13 pi over 12, we can express that in terms of angles where we might be able to figure out the tangents just based on other things we know about the unit circle.
Wait, hold on. Let me search something real quick. Alright. So you're trying to figure out what tangent 13 pi over 12 is. Alright. For reference, 13 pi over 12 is something like this. You have the thingy. the big boy, big juicy, that doesn't even fit on the screen. You have an angle here. This is pi over 12. Right there. So you go like all the way around. That you're looking for this angle. Let me try something real quick. Tangent 13 pi over 12 is equal to sine 13, whatever, sine x over cosine x. And you have to, okay, maybe it's a bit too long. Is there something quicker?
13 pi over 12 is the same thing as 15 pi over 12.
Tangent is still positive? Is it? Sine is negative though. Oh, but cosine is also negative.
2 pi
Alright, so
over
positive
12,
then.
which is the same thing as the tangent of 5 pi over 4 minus pi over 6. Or we could even view it as plus negative pi over 6. So that's my hint right over there. So pause this video and see if you can keep going with this train of reasoning.
Okay, so he's using this method. So just try and turn it into, so basically the method he's saying is to turn it into special angles. So you have 15 pi over 12 minus 2 pi over 12. So that is tangent. What is that? 15 pi, so that's, okay. 5 pi over 4 minus... Bro, click! Over 6. Wait, but I don't know the identity about tangent. I can't do anything.
To evaluate what tangent of 13 pi over 12 is without using a calculator. Alright, now let's keep on going together.
Wait, how do I know? I don't know the identity.
Well, we already know what the tangent of the sum of two angles are. We've proven that in another video.
Oh,
we know that this is going to be...
sorry, I didn't watch that video. It's actually not even here. That's not my fault.
The tangent of the first of these angles, 5
Okay.
pi over 4, plus the tangent of the second angle, tangent of negative pi over 6. All of that is going to be over
Okay.
1 minus tangent of the first angle, 5 pi
First angle.
over 4, times the tangent of the second angle, negative pi over 6.
Shit,
So
alright,
now
bro.
we can
Chill
figure out how
out.
you
Damn,
define this to figure
alright.
out what these things are. So I have pre-put...
Okay. We get it. Okay, we get it. So that's an entire identity that I just don't know. So if you do tangent x plus y equals to tan x plus tan y over 1 minus tan x tan y. I put tay. Whoops. Is that really what it is? Damn. I want background music. Don't worry, it's there. You can listen faintly. I think you can see it. Alright. Okay. That's something. So tangent 5 pi over 4 minus pi over 6. It's faster to write on paper, but whatever. Minus or plus tangent pi over 6 over what is it again? 1 minus this. One minus this value times this value. All right. All right. How do I know what is tangent pi over 6? I'm just going to use my right hand. Tangent pi over 6. Pi over 6 is 30 degrees. Isn't it sine over cosine? So it's 1 over root 3, which is root 3 over 3. Let me verify. Tan 30. Where's... Alright, I'm right. Yeah, like, we all, like, let's assume that we don't know that tangent theta equals sine over cosine. Let's assume we don't know this yet, because, I mean, to be fair, he hasn't really taught that yet. So we know this value is root 3 over 3. What is 5 pi over 4? So we know that... I mean, 5 pi over 4 is over here, right? Oh no, 5 pi is down here. This is pi over 4. Right? This is pi over 4. But and then tangent pi over 4 is 1. Right? Tangent pi over 4 is 45. But it's negative. But no, both sides are negative. Shouldn't this be 1 also? Let me verify this. Tangent 5 pi 1. Alright. So okay, this is the method, by the way, that I was like confused about. It's just to know where it is. I can actually simplify it to 5 over 4. It's like, I don't know what it's called, like reference angle or something like that. So it's actually tangent of 5 over 4 is equal to tangent this. But just remember the sign. Because they're both negative, so it will be 1 positive. So 1 minus root 3 over 3. Alright. Oh god, there's a lot. 1 minus root 3 over 3 over 1 plus tangent yeah. Okay. Do we have to simplify this even more? I mean, let me see that.
But that over the x coordinate here. So the tangent is just going to be negative square root of 2 over 2 over negative square root of 2 over 2.
Okay, look, this is way too complicated, bro. Right, use your right finger, right hand.
Which is once again 1, which was our intuition.
Goodness gracious me.
So we can write that tangent of 5 pi over 4 is equal to 1. And then what about negative pi over 6 in the y direction? To negative 1/2.
I'm not gonna lie, I feel like if this is the way Khan Academy is, I feel like there's like 8 different shortcuts I could have done, but
Over
it's fine.
square root of
He's
3.
showing like the way how to solve it, but I'm just like using my right hand, just memorizing all this
over
shit.
2, which is the same thing as negative 1/2 times, let me write it this way, negative 1/2 times negative 1 over the square root of 3. And so I can rewrite this entire expression as...
Wait, how do you get... Wait, what? How do you get minus? What? How do you get negative? Oh shit! I apologize. It's... Yeah, oops. Whoopsies, it's actually minus over here. They're both minus. My bad. My bad. So instead of pi over 6, it's negative pi over 6. And in that case, it's going to be 1 plus... But it's a negative angle, right? pi over 6, let me look at this again. It's root 3 over 3, but it's minus. So minus root 3 over 3 over 1 minus 1 times negative. So 1, it's just going to be plus, right? It's going to be negative root 3 over 3. Yeah. Answer.
As being equal to
I'm gonna dip. Goodbye.
1 minus 1 over the square root of 3. All of that over, plot out the
1
numerator,
plus.
square, that's tangent
Wait, what? How do you simplify that?
square root of 3. What we're going to get in the numerator is by square root of square root of 3. And if we multiply both the numerator and the denominator by square root of 3,
Oh, he just multiplied both sides by square root 3. I mean, okay. I can do the same thing too. I can multiply both sides by 3, like this. And that's gonna be equal to 3 minus root 3 over 3 plus root 3. Boom! Answer. Wow. So inspirational.
we are done. That's tangent of 13 pi over 12 without using a calculator. In this video, we're going to try to compute what tangent of 13 pi over 12 is with.
Yo, thank you that one channel for the dollar. Dollar. You know what? Screw you. Let's just remove all the thing. Let's multiply both sides by root 3. So 3 root 3 minus 3 over 3. Nah, fuck it. You know what? I don't care anymore. Let me move on. I don't want to do this anymore. Fuck you. So we learned about the tangent angle. I bet. Put Subway Surfer at the bottom.
But I will give you a few.
Tangent angle identity. Alright, so we did this already. So tangent 13 pi over 12. So at least we know how to get this. Tangent 13 pi over 12. So this is another method. Deconstruction equals to tangent. Didn't we do this already? Yeah. Alright. We did the same thing already. Bro, my I can't, I'm so fucking stupid. Let's do this. Alright. I'm working on the card into whirow. Card it right into whirow, bro. That's crazy. Oh my god. Okay, so you can do minus here. Look at that. Wait, what? Oh wait, okay. It's instead of 1 minus, it's 1 plus. Okay, so it's the same thing except it's just negative. Alright, so consider the following equation. So just solve that. Solve this. Solve this. Big, juicy equation right here. Find the exact value of this expression without using a calculator. Alright, bet. Wait, what are we referring to? So this is the same thing as tangent 25 pi over 24 minus 3 pi over 8. So 8, 16, 24. 9 pi over 24. What if I add the two together? That's gonna be tangent 34 over 24. Alright, I thought I was gonna get somewhere if I actually went backwards, but it looks like there's nowhere to go. Oh well. Tan formula looks chop as fuck. Yeah. Why you gotta be so complicated, bro? Why is tangent gotta be like that? 10 actually means tomato. True. Alright, so how do we solve this? I actually don't know. I don't remember. I don't know what 25 over 24 is. What? So what is tangent 1 over 25? 24. 7 I mean that's equal to 0.5 pi over 12, I guess. You on the right track? Oh fuck. No! Wait, no! I was on the right track? 369 34 over 24. I was on the right track. I just looked at it again. So that's equal to tangent. This is, 34 pi. Pi plus 10 over 24, which is 5 over 12. Like that. Okay. We're getting somewhere. So 5 pi over 12. We know that 5 is that pi over 12 is 15. So 5 times 15. God, why is the music so loud? What is 5 pi over 12? That is 75, right? So 15 times 5, 75. So it's this angle and this one is 5 pi over 12. Minus, not plus. The reason I added is because it's minus, right? You have 25 here. 25 minus 9. So I put the two together. Wait, what? Where are we? So now I have to get tangent 5 pi over 12. But you added. Yeah, I'm going reverse. The opposite of minus is adding. Okay, tangent 5 pi over 12. I don't know. What? How? I don't know this. I don't have, it's not on my fingers. Okay, do I just skip? I don't know where to go from here if I don't have a calculator. Let me skip this one. I want to see the solution. Let me skip this one. I want to see how they solve this. Yo, thank you for the $5. What's your major? Well, currently gonna go Bachelor of Science, and then hopefully if my grade gets high enough, I'm gonna go into the honors engineering class. That's pretty much all. That's pretty much what I'm gonna do. Yep, there it is. There's the answer. Alright, let's see here. So this identity matches... Okay, whatever. Pick this one, sure. Okay, I know this. Find a combined angle and evaluating. What? What? Tangent 25 over pi. Okay, he did this. I did this. I think it's the right time to put the Charlie Kirk's son image right now. The one guy was like, why did you add instead of minus? And then I actually gave my reason. Mi bomba! I honestly did not know you can just put the two together. Fuck, okay. I'm sorry for that one chatter who was like, why are you adding instead of subtracting? You're right. And I'm dumb. Whoops. I was going the right way, but also the wrong way. I don't know why, because like I was like, why, if you do negative, if you go, that's why you have the identity, right? So you can subtract, but if you can just subtract the angle, then you just subtract the angle. Alright, consider the following equation. Alright, bet, watch this, chat. I'm gonna gift a membership if I get this wrong. Watch this. Watch this. Sine, cosine, cosine, sine. So we know this is gonna be sine of two angles. Sine of what, though? Pi plus 8 and pi plus 8. That's gonna be pi over 4. It's gonna be pi plus 8 plus pi plus 8. Sine, cos plus cosine. And then pi over 4 is 1. No, root 2 over 2. Oh, shit. Watch this. Ha! I don't gotta spend any money. Cosine, cosine minus sine, sine. Alright, I'm gonna gift the membership if I get this wrong. This is gonna be equal to cosine 3 pi over 4 plus 5 pi over 12. It is equal to cosine 4, 8, 12, 9 plus 5. What? 4, 8, 12, 3, 6, 9 plus 5, 14 cosine 14 pi over 12, which is here. Go down here where this is going to be pi over 6 because the remainder is 2 pi over 12. And so I just have to get cosine pi over 6. And the cosine is actually negative. So pi over 6 is root 3 over 2. It's 30. Yeah, 6, 12, 18. Root 3 over 2, but it's negative. Weirdo, I don't think your fanbase is old enough to understand it. Yeah, you are right. But one thing you should know about me, I don't care about my fans. I hate all my fans. Therefore, I will do math that is above their level, even if they don't get it. Anyways. Whirow, how would you like... Okay. Find tangent of 7 pi over 12 using the angle addition or subtraction formula. Alright. 7 pi over... Wait, didn't we just do that? Fine, let's do it again then. 7 pi over 12, you ask? 7 pi over 12, you shall receive. Alright, that's gonna be equal to 6 pi over 12 plus pi over 12, right? So you do tangent pi over 2, right? I think. Yeah. So you do tangent pi over 2 plus tangent pi over 12 divided by 1 minus tangent pi over 2 tangent pi over 12. Right? Tangent pi over 2 is tan 90 degrees, which is below over above. Wait, what? Pi over 2 is 90 degrees. Oh, fuck. Isn't it 1? Sine over cosine. I definitely got something wrong here. Because pi over 2 is undefined. What did I do wrong? Oh, maybe, okay, maybe I should have, oh my god, don't tell me I have to do a guessing game. It's maybe don't pick these two, don't pick pi over 2. Pick 3 pi over 4 plus, wait, no, 3 pi over 12, sorry, plus 4 pi over 12. There we go. So don't pick pi over 2 because that's an that's an undefined because you're dividing by 0. All right, so tangent 3 pi over 12, which is, by the way, pi over 4 plus tangent 4 pi over 12 divided by 1 minus tangent 3 pi over 12 tangent 4 pi over 12. There you go. Handwriting, you know how it is when you're using a mouse. So tangent 3, so that's pi over 4, which is 1, plus 4 pi over 12. That is pi over 3. Pi over 3 is 60, so root 3, period, root 3. 1 minus 1, because you have root pi, you have this, right? But 1 times, so, okay, remove this. Because 3 pi over 12 is pi over 4, which is 1. So 1 times 1 minus root 3. 366k subs and only 25 real ones. True. Hey, y'all are the real ones, bro. That's the thing about YouTube. I don't know how YouTube works. Like, especially with live streaming. Because, like, here's the thing. YouTube lets you make videos, have community posts, live stream, make shorts, make a podcast, do all of that. But, like, you know, the audience distribution is, like, super weird. Super random. I really don't get it. Anyways, it's 1 plus root 3, 1 minus root 3. I'm just smart like that. The thing is, like for example, for me, I make videos, right? I average like 150k, and then, you know, if it's like a really good video, it gets up to 500k or more, right? Live streaming, I only get, you know, in this case we're at 28 viewers, but if it's like a really good topic, I can get like 100 to a few hundred viewers, which is okay, but like not great, especially for a channel my size, right? And then shorts, they probably only get like 100k at most. Usually they get like 50k. And then the community posts, they get like 500 to like 5,000 likes. And then I've seen that like usually the estimated number of people who like see it or do anything with it, it's like probably double it. So I don't know how YouTube calculates all that. I have no idea how to increase viewership on like anything else but the videos. So, or maybe it's because it's just a people thing. It's not a YouTube thing. Anyways, done yapping. Alright, so this is gonna be a sine. This is definitely a minus thing. So sine pi over 6 minus 5 pi over 12. I think. I don't know which. It's a. It's going to be sine pi over 6, so that's basically 2 pi over 12 minus 5 pi over 12. Alright, so that's going to be equal to sine negative 3 pi over 12. So that's basically sine negative pi over 4. So sine pi over 4 is root 2 over 2, but it's negative. So it's going to be negative root 2 over 2. Aren't we just the greatest? I think there's a quiz after that. I really don't want to do that. Please, please, please. Wait, what? Where are we? Didn't we already do this?
What I want to do in this video is use all of our...
What is this called? Using trig angle to find side lengths. Oh.
Our powers, all of our knowledge.
Can we get out of
trig
trig hell,
functions
please?
and trig ideas, in order to
Please.
figure out, given all the information that we have here, in order to figure out the length of this yellow line, this point, this line that, or the segment that goes from here to here. And I encourage you to pause the video and think about it before I work through it. So I'm assuming you've had a go at it.
Wait, what? I was blanking out.
This
Hold on.
route, given all the information that we have here, in order to figure out the length of this yellow line.
Oh, find the length of the yellow line. Oh god, this is gonna be difficult. But alright. If we can, alright, chat. If we can solve this without him revealing the answer, then I'll skip the topic. I don't think I will though. This looks way too hard for my puny brain. But we'll give it a shot. I think you guys can see it. Fuck. And you have another one. Like this. No, what the heck? Let's do like this. I cannot. There you go. God, bro! Close enough. Alright, so this is x, angle y. This is 1, 0.8. So this entire thing is 1, 0.5. Okay. Root 3 over 2. And we have to solve something that bisects this. Alright. I've never seen this. Khan Academy is just it's just different, man. I don't know what to tell you. So we have to solve for this. How though? All right. So let's do the same thing that he did. We can make a line here. And that's all I can really think of. I mean, we can solve for x and y. We can solve for them. Alright. Let's see. I think we can solve it with... What do I use, though? Law of cosines, maybe? Is there another way to solve it, or do I have to use law of cosines? I think we can. Oh wait, no, we can just get like arc this. Like for example, cosine x is equal to like you know what, screw you. Let's use sine x. Sine x is equal to 0.5 times 1. No, opposite over hypotenuse, sorry, over 1/2 over 1, so it's just going to be 1/2. Alright. Which is 1/2? 1. Just pull the number out of nowhere and lie. Wait, it's not a bad idea. So, okay, we can just say arc sine of 1/2. Or we can do maybe let's just solve, we can solve for both of them. So we can do sine x plus y equals sine x cos y plus cos x sine y. We can do this. And then we can just arc sine this later. Yeah. Get this entire thing. Oh, you're right. Very smart. Alright, so sine x. What is sine x? 0.5. 0.5 cosine times cosine of y. Cosine of y is... Fuck, we don't know this one yet. Alright, we'll skip that. Plus... You can see sine x is 0.5. It's like right here. Because this is 1. And this is also 1. So... Okay, cosine x is root 3 over 2. Sine y is 0.8. Alright, so basically cos y over 2 plus root 3 over 2, but it's times 0.8. So it's times 8 out of 10, which is times 4 out of 5, which just makes us 4 over 10, or 2/5, sorry. We can do that also. What the heck? Not that. Because this is times 8 over 10, which is 2/5, or 4/5. Like that. Times 4/5. Yeah. And then put this together, going to be 4 over 10, or 2/5. So 2/5. You have two sides of that top triangle, right? So how would you get the third? Oh, you can Pythagorean. You're right. Damn, bro. It's like you can. I can remember these things like individually, but like it's stuff like this. You have to like put them together. For example, this one I can use law of cosines, or just remember the fact that like it's not needed because you already have all the sides. There's no point. Bad word. Chat spam, bad word, bro. We're not gonna say any more bad words in this stream. I promise. Okay, maybe I don't promise. X squared plus 0.8, which is 4/5 squared, equals 1. So that is 16 over 25 plus x squared. So x squared is equal to 1 minus this. So 1. 25 minus 16 is 9. So x is equal to 3/5. 0.6. Alright. So cosine y is 3/5. So 3 over 5 over 2. But what is that? Isn't that just times? Isn't that 3/10, right? 3/10 plus. We can actually multiply both sides. So 4√3 over 10. Can we combine this? 4√3 and then put it in there. It's 16 times 3, which is 48. Is there anything? Anything? I don't think so. Okay, what are the squares? 4. I mean, there's just 4 times 12. So you can just do √2. I don't think so. Let's just keep it like that. That's the answer. This value. I think last time we solved this, it was like a big proof that that was right. But yeah. Okay, so now we can actually solve it because we know the identities and all that, so we can solve for this entire thing. It was just a simple formula. We got it. Watching paint dry more entertaining? Then why are you watching it? Wait, hold on. Oh, my package. It's still expected by 17th. Fuck. Oh well. Alright. YouTube said I'm top 0.1%. Oh. Oh boy. Alright, I think we did this. Check the video.
Point, this line that, or the segment.
Hello,
that goes
Alan
from
underscore.
here to here. We know it's the same thing as the sine, as I'm going to write that as 4. Now this, if I want to write it over 10, this is the same thing as 4 plus 4 square roots of 3. All of that over all of that.
I'm so smart, bro. I definitely did not get any help from this. Wow.
What I want.
0.6 is. Okay, we. Fuck. I didn't even see. It was given. Now you can just Pythagorean that. Whatever. Okay, bro. My bad. I did not see that. I did it. I'm actually like the smartest person in the world. World, you have a Discord server. For members only. For members only. Alright, using trig, angle, addition, identities, manipulating expressions. Really?
Sine of 2
Oh, really?
is equal to C.
Sine 2 of something is C, and
theta
is between 0 and pi.
Write
Right?
A
A formula
sine
for
of
sine theta in terms of C. Okay. And C is an angle between... Okay. Make it not members only. The reason I have it as members only is because I don't want too many people to join. I'm gatekeeping on purpose. I don't want to moderate that shit that much. Oh wait, let me check my editor. All right, let's see. So, oh, we have to get sine theta. Okay, so we have to turn cosine 2 theta into sine theta. All right, let's see what we can do here. So we know that, alright, it's an interesting exercise. Cosine 2 theta equals 2 cosine squared theta. Was it 1 minus or minus 1? Shit. Minus 1 or 1 minus? Fuck. Let me try and search it up. One minus. So we know that. Okay, I just remember that cosine of 2 theta is like cosine minus sine and shit like that. Minus 1. Let me do the other one where it's cosine squared minus sine squared. Alright. Cosine squared minus sine squared. Let's see if maybe we can do it from here. Alright, just remember this. I don't care if you're not writing the angle, screw you. Cosine squared is equal to 1 minus sine squared, so 1 minus sine squared. Alright. Alright. There we go. Look at that. Okay. So it's actually this one. 1 minus, not minus 1. 1 minus sine squared. But it's also minus. So minus. So 1 minus 2 c squared equals to. Oh, but they have to write sine squared. Fuck. Okay. Okay, let me write that down. Let me write this down. So this is 2. Write it down! Cos 2 theta. Alright, bet. There you go. This is pretty basic. Damn, chill, alright? We're just getting started. Where do I go though? So if a cos, we have to write a form. We have to isolate sine theta. But we have to write a formula for sine theta in terms of c. Shit. All right. Okay. Let me see what I can do here. So we have to isolate sine theta. Oh. Maybe I want to start here then. Cosine 2 theta minus cosine squared theta equals negative sine squared. So, okay. And then just make this positive, make this negative. Square root the entire thing. So you have sine theta equals sine theta equals that thing. Root of the entire thing. Sine x equals c. No, because look, here, it's right here. Cosine 2 theta is equal to c. So minus c plus, but can we write this in terms of c also? Cosine squared theta. What is cosine squared theta? I mean, you can go back to this. cosine squared theta is cosine 2 theta minus sine squared theta. Or no, plus. If you move it on the other side. But are we not like not allowed to just like use the same formula in this formula? I think that's... Yeah. Plus C. Yeah, because you're just gonna get 0. You just can't use the same. You can't use the same formula. You can't substitute one formula and put it in the same formula. I mean, this is good enough. 1 minus... No, why is there a 1 there? There. This is my answer. Good enough. This is there. It's under root. Let me check my answer.
In of angle addition formulas, we know, for example, that
Thanks, Space, for the membership.
Alpha.
Yeah, cosine of 1 minus 2 sine squared theta. Yeah. So I mean I can also write minus C plus 1 minus 2 sine squared. But I mean, like, do we have to go, like, do we have to keep doing this? Is equal to sine theta. And this is all rooted, by the way. And we have sine squared plus cosine squared equals 1. We have this. We have this formula. And we can evaluate, but it's not the same. It's 2 theta.
Alpha plus beta. We know that cosine of alpha plus
Please
beta.
tell me I'm right.
So I can rewrite
Please,
cosine of
please.
Cosine of theta.
Oh, don't freaking tell me, bro.
Plus theta, sine of theta, which is of
Okay.
course.
So it's
equal
cosine
to
minus cosine squared minus sine squared. I mean, okay, we know
theta
that.
is equal to 1, or sine squared theta, and all of this is equal to sine squared theta. And what's useful about
Fuck. Oh
this is
no.
now we just have to
Wait. Hold on here.
solve for sine of theta. So let's see. I could multiply both sides by a negative just so that I can switch the order over here. So
Okay, so basically he made this, he expanded it into, you know, cos sine because cosine of 2 theta is equal to cosine of theta plus theta. So you can say that this is equal to 1 minus 2 sine squared theta.
C is equal to 2 sine squared theta.
2 sine squared theta minus 1.
It's by 2.
Wait, what? How do we get this? Cosine squared is equal to 1 minus... Wait, let me go back.
Minus 1. Let's multiply both sides by negative. And then, let's see, I could add 1 to both sides. If I add 1 to both sides...
Oh, he adds 1 to both sides.
I can divide...
Yeah, it's 1 minus... Okay, I get
2.
it.
Divide both sides by 2.
And then he divide both sides by 2.
And so I get sine of 1 minus c over 2. Of 1 minus c.
Wait, what? Sine theta is equal to root... Okay, duh.
Over 2. So that leaves...
Okay, I'll give myself like half a point.
leads to a question. Is it both? Is it the plus and minus square root, or is it just one of those?
Oh, no. It can't be the minus because it's a sine value.
And I encourage you to pause the video again in case you haven't already figured it out.
You can't do
Well,
it if
they
it's
tell
rad,
us-
bro.
They tell
It's between 0 and
us
pi.
that theta at this angle right over here. This angle places its terminal, I guess its terminal ray, either in the first or second quadrant.
Bro, whoops.
So it could be an angle like this. It could be an angle like this. It cannot be an angle like this. And we know that the sine of an angle, 2. So let's go back to our, make sure that we can, all of that.
Oh my god, bro.
All of that over 2. And we got it right.
Okay, bro, whatever. Whatever. How did he do it again? So he turned... Okay, so you have this value, so C. So he basically turned this value into sine, and then he isolated sine. Okay, so what he did is he converted C into a thing with sine, and then he isolated sine. What did I do? I kind of just bullshit. I'm not even gonna lie, bro. I didn't know where this was going. Okay, well, this is stupid. What are we doing here? You just left as cosine. Okay, well, I should have. Yeah. Exactly, you're not wrong. See, it said make a formula for sine in terms of C. I gave a formula for sine in terms of C. Or maybe because it had cosine theta also. Maybe that's why I was wrong.
Let's do some examples simplifying trigonometric expressions. So let's say that I have
okay, what is this called? Using trig identities. We've been using it like
sine
the entire stream.
Squared theta, and this whole thing times cosine squared theta. So how could I simplify?
Okay, so that's cosine squared minus sine squared times cosine squared. Wait, no, 1 minus sine squared, isn't that cosine squared anyway? So it's cosine to the 4th?
Option theta with the cosine times another
Alright, see? Alright, bet.
Sine over sine squared theta.
I think this is like one of my favorite lessons, simplifying. Instead of making it even more stupid, even longer, you make it shorter. Why are you mute? I'm not mute. Don't troll me like this. Sine squared over cosine squared is just tangent squared.
Theta, fine. That's tangent. So this is equal squared theta plus 1 minus plus. Well, you might be tempted, especially with where you got
plus 1 plus. That's 2. Alright. Okay, cool. Trig identity reference. Oh, we have an entire doc of trig identities. Alright, bet. We have secant, which is 1 over... Okay, I kind of forgot this. Yo, Google, stop it. Secant, cosecant, and cotangent. Alright, 1 over. Alright. Pythagorean. Tan squared plus 1. Okay. Sine plus cosine is 1. Tangent squared plus 1 is secant. Cotangent is cosecant. Thank you for the cheat sheet. Alright. Alright. Sums. Alright. Yeah. Sine, cosine plus cosine. This is sine, cosine minus cosine. Cosine, sine. Alright. It is the same thing except, look. It's just the sign, the plus and minus are switched. So tangent of theta plus phi, is that phi? I don't remember. Tangent plus tangent of 1 plus tangent of 2 all over 1 minus. Alright. Double angle identities. Ooh, Oh! It only matters when you're trying to make it faster. True. Okay, so we remember that sine is 2 sine cos. Wait, no. cosine of 2 is 2 cosine squared minus 1. Alright, it's not 1 minus, it's 2 cosine squared minus 1. Alright. And tangent is 2 tangent of the theta all over 1 minus tangent squared. Alright, so move this here all over 1 minus tangent squared. Half angle, which is we just never use them. I don't want to do this, bro. So 1 minus cosine squared. Wait, no, because... Damn. Symmetry, alright, this one we know. Tangent of minus... Alright, it's only cosine where the angle, the negative angle is equal to the positive. I have never used half angle day of my... Alright, bet. I will not remember this because I don't want to remember that. Just, like, memorizing this is good enough. Double angle, the addition ones. The addition ones are actually useful. I don't want to use half angle. Double angle, I mean, I kind of already learned them, so... 2 tangent theta all over 1 minus tangent squared. 2 tan theta over 1 minus tangent squared. Just multiply theta by 2 and you have the same equations. Damn is. God, this comment will not leave, huh? Co-function identities? I mean, yeah. Because they're what do you call it? They're complementary. Appendix. Okay, so let's say, okay, so sine is up, cosine is the y value or the x value. Tangent is a line that really goes... What the flip? Secant is this line here. Cosecant is up. Cotangent is just this one on the side. Okay, interesting. Hi, whirow, I'm gooning to this. Can you please call me a good boy? Shut up. You're an awful guy. Please stop. What is this entire thing? Tangent means touching. The line that touches the curve. Something. Ah, whatever. Whatever, bro. Whatever. Do I leave trigonometry? Are we leaving trigonometry once and for all? What is a unit circle? A unit circle is a circle, duh. Law of sine, cosine, yeah. Law of cosine is a squared is equal to b squared plus c squared minus 2. The other two sides here, cosine of this. Angle addition identity. Alright, usually I skip the quizzes, but fine, let's do it. Alright. Solve for x. Oh my god. Ah! Alright, please tell me if I solve all of these, I can finally escape trigonometry. So sine... Oh, wait, hold on. Yo, thank you for the $2. Hi. Hello. How's it going, man? Appreciate the dono. So sine 20x is equal to... Okay, add 3 on both sides and then divide by 14. So 5 divided by 14. Yeah. Alright. So let's arc sine both sides. So 20x is equal to sine minus 1. 5/14. Yo, for the membership again. And again! You know, Swayze, dude, I feel like you've given me more money than that one guy who gave like 100 gifted. I appreciate the 100 gifted on the guy. It was crazy, but Argentina's currency is so low. I checked the stream. I got like $5 from all that. But yeah, anyways. Anyhow. Wait, let me check the chat. Yo, where my load shot onto the subscribe and like button. Hey, whatever makes you hit that subscribe button, bro. Whatever. Wait, aren't those supposed to be GIFs? Why are the GIFs not loading? They're supposed to be animated. Okay, whatever, bro. Alright. So, oh wait, how do I do this again? I already forgot. So, sine of 20x is equal to 5/14. Okay. What are we looking for here? In radians. Okay, bet. Sine of an angle. I have not mastered it, by the way. As you can tell. Let me try to remember, because I was too focused on the freaking identities and shit. So you have x is equal to, let's say sine x is equal to 5, or let's say 1. Solve for x. Alright, so x is equal to, okay, sine minus man of 1 plus 2 pi n. And then it's also, where's the thing where it's like minus something? 180 minus or something like that? This is one scenario. Like, fine. Sine minus 1, 5/14. Goodbye, green whirow. No. 0.365. So 0.365 plus 2 pi n. Isn't there supposed to be some other value? I think it was pi minus 0.365, like that, or something like that. How is it that cheap? So pi minus wait, let me show you guys. I don't know why I was doing it on another tab. God, I can't speak. All right, so pi minus that, it's 2.776 plus 2 pi n, right? Plus 2 pi n. This one. Wait, isn't it supposed to be divided by 20? Because 2.77 is 20x. So plus 2 pi n n equals 1. And like, it's basically like all this divided by 20. Divided by 20, so you get 0.138. And then this one. Yeah, I didn't fall for it, alright? I actually, I'm super smart, you know? Like that. Divided by 20. So this is one solution. And the other solution is this. X. Sorry, no, why did I write X? 20. There you go. 20 like that. Let's just, instead of doing pi minus, do this, divided by 20. 0.01? Let me check again. Over here. Keep going on the wrong tab. There. Alright. Please, please, I'm right. Ooh! That's power right there, bro. What's the best ice cream flavor? The best ice cream flavor is coffee flavor. Okay, wait. Let me defend my stance here. I don't drink coffee for the caffeine. I drink it because it tastes good. But I'm not gonna lie, if it's not coffee flavor, I think like a super close second place has to be ube flavored ice cream. I would not last 2 seconds doing it low key. Thanks for the $5. Hey, you gotta last at least 5 seconds. Hey, I'm just saying. If you guys go to the Philippines, get ube flavored ice cream. That is like, mwah. It's beautiful. Anyways, an astronomer is 450 light years from star A and 400 light years from star B. Alright, star A is 90 light years from star B. Right? If the astronomer's telescope is currently pointing at star A, how many degrees must it rotate to see star B? Okay. Alright. Oh, I understand why last time we didn't need law of cosines or any of that. I understand now. Because those ones were 90 degrees, they were right triangles. So we can just get the sine and cosine. But the law of sine, law of cosine can work for any triangle. That's why it works. I was like, why do we need this? Anyways, now we know. So, we should know that cosine... No, not... Fuck, what am I doing? 90 squared equals 400 squared plus 450 squared minus 2 times 400 times 450 times cosine theta. Okay, you know what? Desmos, do the thing. 90 squared is equal to 400 squared plus 450 squared minus 2 times 400 times 450 times cosine x. We've been pre-calc for a week now. Nothing happening on the studying front. What do you mean? We're actually making progress here. I think we should skip, definitely. I definitely agree we should skip a bit because it's getting a bit slow. Especially because I don't think I have much time. Where are we, by the way? Are you answering in degrees? All right, we're in degrees. What is the answer? Damn, those are big numbers. So it's definitely this value. 10 degrees? Alright. Cool. Awesome. Got it right. So smart. Consider the following equation. Find the exact value of this expression without a calculator. Alright, bet. Please, get me out of trig, bro. I'm done with trig. Isn't Desmos basically cheating? I mean, I could do the same thing by just like, you know, using a regular calculator to isolate cosine. You know, but I don't. But you know what? You know how it is. Fine. Let's see what we can do if we actually do this. So we have this, and then divide everything by this. Oh wait. All right. And now we have cos x. Wait, negative 800. Alright, this is cosine x is equal to this value. Let's get this value. What is this? So 0.98. So 0.98 is equal to cos x. Right, let's say... Wait, what? 9844. Alright. That's why. 984444. Let's say we don't know this. Alright? And we don't have this graph. So if this is cosine x, don't we just arc cosine both. So we just do cos minus 1 and there's the answer. I mean, in trig, like, you're allowed to use like a regular algebraic boring ass calculator, so you should be able to do this. Evening for 2 weeks. What do you mean 2 weeks? We haven't even done 7 streams yet. It hasn't even been 1 week. Well, technically it has been like over a week, but like I skipped a few days. Anyways, this is cosine 7 pi. Fuck! Answer correctly! 7 pi over 4 plus 5 pi over 12. And you have to add the two together. What is that? 4, 8, 12. 21 plus 5, 26. So it's equal to pi plus, what's that, 12, 24, so 2 pi. So if it's 2 pi, then you can just discard it. 2 pi 24 plus 2 over 12, which is pi over 6. And pi over 6 is 30, so root 3 over 2. I'm gonna boss! I'm gonna boss! Sarah and Arabella are on 2 swings of a swing set. The function s of t represents Sarah's height in meters. From the ground, t seconds after a bell rings. Alright. Likewise, it represents our height on the ground t seconds after the bell rings. Alright, so the same thing, except there's just 2 different ones. Consider the following equation. Okay, 1, 4 plus sine. They're equal. What does the least positive solution for the equation represent? So the lowest solution is when their heights equal. Right? Don't tell me I have to solve this, bro. The difference in height above the ground. No, we're looking for time. What is the least positive solution? The number of seconds after the bell when Sarah are first are the same height above the ground. This one. Yeah. Alright, last one. Just don't mess this up. L of t models the length of each day in minutes in Manila. Oh my god! Oh shit! Oh my god! Oh, this is the best day ever! I'm so jolly! Oh my god. Oh, it's everywhere. Oh, it's everywhere. After the spring equinox, here T is entered in radians. What is the first day after the spring equinox that the length day, okay, is 750 minutes. So we have to find the lowest. So it says that we have to find the lowest solution where it's 750. Okay, so this is equal to 750. If I can type correctly. Alright. Minus 728. That is 22 divided by 52 sine 2 pi over 365 t. By the way, 365, so t lower than 365. Also, it's 52 sine. So it's 52 plus 728. So remember, it's a sine value, right? We'll figure it out. I'll figure it out. 22 divided by 52. Okay. How do I simplify that? 11 over 26. Alright. So 11 over 26. Oh, but like 0.423. Okay, wait, hold on. 2 pi over 365 t is equal to what's it again? 0.423 23 plus 2 pi n, and then there's also the one where it's going to be pi minus, right? It's going to be 0.423, but it's going to be pi minus 0.423 plus 2 pi n. And then there you go, and then just solve for it, and then just do t. So multiply both sides by 365. You know what? Fuck it. Let's just make it quicker. We're already here. So 2 pi t 365 is equal to 0.423 plus 2 pi. And you have another one where it's going to be pi minus, and also going to be 2 pi. Alright, so Oh my god, what? Apply n. N equals 0. There we go. There we go. Alright, makes sense now. And the lowest value is 24, 25. If I'm wrong, then I'll give the membership. What did I fucking say? What did I fucking say, bro? There's a unit test? Yeah, you know, screw you. I'm not doing that. Guys, you get the point, okay? We're done with Trig. Get me out of here. Get me the hell out of here. Okay, I think there's way too much, bro. We're gonna be... It's been 6 streams. I think like 2 of them are for... one or 2 of them was for pre-algebra. Was for like algebra and shit. And pre-calc, it's been like 4 streams. So... God, there's a lot left. I want to go to calculus already, but... Alright. It's been 2 hours. Skip complex. Alright. Here's the plan. We're gonna do a little bit of complex numbers, because I don't think it's that important, honestly. Like, when are you gonna use complex numbers, bro? Are you Einstein? I don't think so. Rational functions, okay, we're gonna do a little bit, but we're probably gonna skip a lot of this. We're going to go maybe rational expressions, maybe. Rational function, it might be important. Conic sections, I mean, I know this already. Like, I know this. But we'll do a little bit. So, mostly gonna do unit 4. Unit 6, vectors. Okay, I'll do everything in vectors, because I don't know linear algebra. I did not learn this, so that's important. This is also important. I don't want to do combinatorics, bro. Oh, okay, complex numbers come up with differential equations. All right, bet. All right. I think I'll stream for like another 30 minutes, and then that 30 minutes is gonna be for complex numbers, and then tomorrow we're gonna do a little bit more of complex, and then we're gonna move on to rational. But yeah, let me take a break for a little bit. I need to do something. Let's all for never forget 1 plus. Jesus Christ. All right. I just got some water. Let's probably do like 20 minutes of the next lesson, and yeah. I'm just happy I'm out of trig. I'm out of trig. I'm out of trig. Get me out of there. Please. God damn, bro. Trig is just killing me. Alright. Let's see. Complex plane. Wow. Jelly bean is low-key bad. IRL. Real. What do you have to say about this? What? Oh, hell nah. Why are we doing jelly bean like this again? Like, let's move on.
Move the orange dot to -2 plus 2i. So we have a complex number here. It has a real part, negative.
Here we go.
It has an imaginary part.
Where I
with
squared is
2
equal to negative
times
1.
I. And what you see here is we're going to plot it on this kind of two-dimensional grid, but it's not our traditional coordinate axes. In our traditional coordinate axis, you're plotting a real x value versus a real y coordinate. Here, on the horizontal axis, that's going to be the real part of our complex number, and our vertical axis is going to be the imaginary part. So in this example, this complex number, our real part is the -2, and then our imaginary part is a +2. And so that right over there in the complex plane is the point -2 plus 2i.
Okay.
Let's do a few more of these.
What is this
So
website,
5
bro?
plus
Like,
2i.
what happened to this
Once
website?
Again, real part is 5, imaginary part is 2, and we're done. Let's do 2 more of these. 1 plus 5i.
Okay. Wow, that took like 2 seconds. The imaginary unit is where I squared is equal to -1. I think I heard, like, there was like some talk about, like, technically speaking, I is not equal to square root of -1. It only means that I squared is equal to -1. But, like, shut up about it. A complex number is any number that can be written as a plus bi, where I is the imaginary unit and a and b are real numbers. Okay, bet. Real imaginary. Complex plane. Okay, plotting. -4 plus 7i, so here. Okay, you get the point. In Pythagoras' days, the existence of a rational number was a surprising discovery. They wondered how something like square root of 2 can exist without an accurate, complete decimal expansion. The real number line, however, helps rectify this dilemma, because the root of 2 has a specific location on the real number line, showing that it's indeed a real number. Likewise, every complex number does indeed exist because it corresponds to an exact location on the complex plane. Perhaps being able to visualize these numbers, we can understand that calling it is an unfortunate misnomer. Imaginary. Oh, are we just plotting? Wait, it's like the easiest thing in the world. Alright, I like this. I like this a lot. This is my kind of math right here. Alright, bet. Graphically add plot z1 minus z2, so -4 plus 6, so 2 here. Okay. Oh no, oh no. Okay, z1 plus z2. The z1 is here, and then z2 is, alright, so we're at -3, so move back 3, and then it's up by 5. So go up by 5. Z1 minus Z2. Alright, so Z2 is at minus 8, so let's add 8. 3. Z2 is at 7, so let's minus 7. Negative 4. Yo, thanks again for the $2. A little birdie told me that Jelly Bean is low. Alright, bro. Z2 is minus 2. Go back 2, and then minus 3. So go down to 7. Hey, it's like the easiest thing ever. Oh no.
So we have two complex numbers here. The complex number z is equal to 2 plus 3i, and the complex number w is equal to negative 5 minus I. And what I want to do in this video is to first plot these two complex numbers on the complex plane.
What did you do?
Think about what the distance is between these two numbers on the plane, and what complex number is exactly halfway between.
Wait, by the way, I think my cropping's a bit off. I feel like it should be like that. But like, guys, I don't want you guys to see it. What's on the top over there? Who cares?
Between these two numbers, or another way of thinking about it, what complex number is the midpoint between these two numbers? So I encourage you to pause this video and think about it on your own before I work through it. So let's first try to plot these on the complex. 2 plus 3i.
So don't you just get the midpoint of like the real and the complex in like at the same time? Like the real, the difference is 7. Right? So the midpoint is 1. Or negative 1. 0, 1, 2, 2, 3, 4. 0.5. Negative 1.5. And then 3 is going to be 2i? Or no, I, like 1i.
2 more to get to 2. So the length of this right over here is 7. And what is... So the distance in the complex plane between these two complex numbers?
Oh, we're looking at the distance.
Square root of 65, which is, I guess, a little bit over 8. Now, what about the complex number that is exactly halfway between these two?
Sorry.
Well, to figure that out, we just have to figure out what number has a real part that is halfway between these two real parts,
So
and what
this
number
is
has an
distance.
imaginary part that's half.
How do you just have a distance? Isn't that supposed to be I?
3 minus 3 plus 3, negative 3 halves plus I is the midpoint between those two, and if we plot it, we can verify that actually makes sense.
Oh, all right.
So real part negative 3 halves, so that's negative 1, negative 1
Five.
and a half. So it'll be right over there, and then plus.
Okay, looks easy enough. Distance between Z1 and Z2. Okay, this is like I know how to do it. It's just annoying. This is negative 8. And this is 4. So the distance is... Okay. Alright. This is the zoo. But negative 7 and this is negative 3. 6, 5, 4, 3. So I guess, okay, like this? Is it like that? What did I do wrong? Okay, I guess the entire time you don't want me to use fractions, and then the entire time you were making me do you were making me convert cosine arc tangent into decimals, and now you want me to actually use this. Okay. Whatever, bro. I'm skipping this. We already know about distance and midpoint. We know this already. Let's skip that. Complex number conjugates. What is this? Interesting. It's a conjugate.
We're asked to find the conjugate of the complex number 7 minus 5i. And what you're going to find in this video is finding the conjugate of a complex number is shockingly easy. It's really the same as this number. I should say be a little bit more particular. It has the same real part. So the conjugate of this is going to have the
What's a
exact
conjugate?
same real part. But its imaginary part is going to have the opposite sign. So instead of having a negative 5i,
That's
it
it?
will have a positive 5i. So that right there is the complex conjugate of 7 minus 5i.
The fuck?
And sometimes the notation for doing that is you'll take 7 minus 5i.
You treat the real
You
and
have
imaginary
7
component
minus
like x
5i.
and y components.
7 minus 5.
Yeah, that's why I skipped the midpoint and the distance, because, like, I mean, Khan Academy is telling me to just treat the two like x and y axes. So what's the difference? I mean, I already learned that, and I'm confident that. So
And you put a line over it like that. That means I want the conjugate of 7 minus 5i, and that will equal 7 plus 5i. Or sometimes someone will write, you'll see z is the variable that people often use for complex numbers. If z is 7 minus 5i, if z is 7 minus 5i, then they'll say the complex conjugate of z, you put that line over the z, is going to be 7 plus 5i. Now you're probably saying, okay, fairly straightforward to find a conjugate of a complex number, but what is it good for? And the simplest reason, or the most basic place where this is useful, is when you multiply any complex number times its conjugate, you're going to get a real number. And I want to emphasize, this
Wait,
right
what?
here is you're going to get a real number.
Oh, so when you multiply a conjugate and its normal self, you get a real
And I
number.
want to emphasize, this right here is the conjugate. 7 plus 5i is the conjugate of 7 minus 5i. But 7 minus 5i is also the conjugate of 7 plus 5i for obvious reasons. If you started with this and
Alright,
changed
where are
the
we going
sign
with
of the
this?
imaginary part, you would get 7 minus 5i. They're conjugates of each other. But let me show you that when I multiply complex conjugates that I get a real number.
But how
So
do you
let's
multiply
7
conjugates
minus
then?
5i times 7 plus 5i.
Isn't that
And
just
I will
like
do that in blue.
25 negative?
7 minus 5i times 7 plus
Wait, do we just
5i.
FOIL?
And remember, whenever you multiply these expressions, you really just have to multiply every term times each other. You could do the distributive property twice. You could do something
What's
like
the fact?
What's
the fact?
times I.
Okay.
And these two guys over
Oh, that's why. Because it's you foil it. You foil it, and the i's are cancelled.
here cancel out, and we're just left with 49 plus 25.
Which is 76,
50 plus
74.
25 is 75. So this is just 74. So we are just left with the real number 74. Another way to do it, you don't even
I'm gonna go to
have to
mathheads.net.
do all this distributive property. You might just recognize that this looks like this is something plus something times, or something minus something times that same something plus something. And we know this pattern from our early algebra that a plus b times a minus b is equal to
A squared minus b squared.
b squared is equal to a difference of squares. And so in this case, a is 7, a squared is 49, and b in this case is 5i. b squared is 5i squared, which is 25i squared, which is negative 25. And we're subtracting that. So it's going to be positive plus 25,
What?
which is negative 25. And we're subtracting that. So squared, which is 25i squared.
Yeah, it's a difference of two squares. Yeah. So it's 49 minus, but plus 25 I squared, which is negative 1. Okay, so it's 49 minus b squared. B squared is 25, so minus 25, but I squared is negative 1. So it's going to be plus 25. All right.
Negative.
Had to wrap it in my mind because I'm used to it being minus, but it's plus because it's an imaginary number. Okay, this looks okay, I guess. Forgot about that, basic algebra stuff. The difference of squares and all that. Please, YouTube, stop pausing my video. My music. Plus conjugate. Okay. Alright. Find the complex conjugate of that. So 8 minus I. Here. Find the conjugate of 9 plus 3i. Okay. Dividing complex numbers.
We're asked to divide, and we're dividing 6 plus...
We're all stop learning school boring. We're gonna end in like... After we finish this... After we finish this unit, then we'll finish.
3i by 7. So I want to multiply.
So how do you divide them? How do you divide? That's a good question. How do you divide? I have always wondered how to divide two complex numbers on an imaginary plane.
So it could be an...
For no particular reason at all, and definitely not because I'm a fucking nerd and all that.
Then we will get rid of, or we will have a real number in the denominator.
Good boy.
So let's do that. So let's multiply the numerator and the denominator by the conjugate of this. So 7 plus 5i. Plus 7 plus 5i is the complex conjugate of 7 minus...
Wait, what? Okay, so when we divide, we multiply both sides by its conjugate. Okay, so to get rid of the denominator, and then you do the thing and you FOIL, and then the bottom turns into a real number. Okay, and then you add like terms. You add like terms, and where did 51 come from? 51i.
74 plus 51 over 74 times I. And we are...
Oh, okay. So we simplify it even more. Add the like terms.
He's adding both of these terms.
Oh, never mind. I forgot that they always have a real component and an imaginary component. So you turn into that. All right, bet. All right, we can do that. Like, good thing we're out of stupid trig and we're into something easier. Thank God. I'm so happy. I've never been happy in my life. Trying to remember freaking tangent. My pain. My pain's always about it. Instead of thinking about dividing mangoes. Okay, bro. So first, divide both sides by the conjugate. All right. So the multiply both the numerator and the denominator by its what do you call it? Conjugate. So minus 3 minus 5i. All right. And then you do the thing. So it's equal to a squared minus b squared. But this time it's gonna be a squared plus b squared. Right, difference of two squares. This time we're going the opposite direction. A plus b, a minus b. So what is root 3 or minus 3 minus 3, which is 9 plus 25, right? Which is 36, and then you FOIL this one. So which is negative 30. What is that? Minus 50i minus 120i. Oh, but it gets so confusing when you're multiplying I squared and I squared. Like when you're getting I squared with all this. So you have, look at this, positive times negative, right? Which is 200, but it's I squared, so it's negative. So it's supposed to be negative 200, but it's actually positive 200. Fuck! 200 minus 30, which is 170. Minus minus, so minus or over 36 minus 50 minus 20, which is minus 70 I over 36. Answer. Don't tell me to simplify, please. I don't want to simplify. How could I have possibly gotten this wrong? Oh my god, I wrote 36 into 34? Oh my god, that's embarrassing. Okay. Oh, there was a 1 there! There was a 1 here! There was a 1 there. Oh, and then you have to simplify. Okay. You have to simplify. You have to simplify your answer. I know you're supposed to simplify, but I don't want to. Okay, so first problem. Alright, bro. Fine. Want me to freaking simplify, bro? I'm gonna fucking kill you. I'm actually hungry. Times minus 4. I have to go closer, bro. Like, why am I like? There you go. Times minus 4 minus 5i. Okay. So it's going to be 16 plus 25, which is wait, 16 plus 25, which is 41. Am I right? 36 plus 5, 41. Don't want to mess this up again, bro. First, which is 980, 27, 36, negative. Outer, so minus 45i. Inner, or plus 4i last. 5, but it's also negative, so minus 5. Minus 36 minus 5, which is actually minus 41 over 41 minus, oh, but it's plus minus 41i over 41. So it's basically 1 minus 1i. 1 minus I. How did I get it wrong? Bro, this is like, this is throwing on a brand new level, bro. How did I get that wrong? Oh my god. Shival. Alright, let's do this. Come on, give me one right, bro. Come on. Please. Come on, give me one right, please. 1. So 4 plus 1. It's negative I times I, which is supposed to be negative I, but it's negative I squared. Yeah, whatever. Whatever, you get the point. Over first, which is negative 2. Outer, which is plus I. Inner, minus 16I. Last. It's supposed to be 8I squared, but it's minus 8. 5. Minus 2 minus 8, which is minus 10. So minus 2. What is this? Plus I minus 16, so minus 15I over 5, so minus 3I. Give me 1, right? Thank you. I don't even know if I learned this in school, bro. Philippine high school, Philippine education, truly, like truly a marvel. 8th grade, alright, bet. 3 minus I. Oops, that's not an I. 3 minus I. Let's go 9 plus 1, so 10. 9 plus 10, 21, you know. And then you do first, which is 8I. Oh, first, stupid. Negative 8 times 3, negative 24. Plus 8I minus 18. There's 18, yeah, 18I minus 6. Yeah. 24 minus 6 is negative 3. 8 minus 18 is minus I. Yeah. Alright. Okay, let's see this and then we'll end stream. How do you divide? You do the thing that I just told you to do! Why did you do this right after the quiz? Oh, I guess it's a review. Okay. Alright. Pick a random one. Alright, we're done. Alright, tomorrow we're going to do the same thing. We're probably gonna just go we're probably just going to... Do we want to do this? I don't know if we want to. Okay, tomorrow we're probably gonna do like a very short, maybe like another half an hour on this, and then we're gonna move on to rational. Hey, it's been 2 hours and 40. I actually kept my promise. We're actually doing a lot of math. We're actually studying quite a bit. Alright, good progress today, not too bad. We learned a little bit about complex numbers. We learned the tangent angle identity. And we actually mastered quite a bit about trig. Good luck with your exams, thank you. Alright, y'all know the drill. Every day at whatever time I want. Around this time. You get the point. Alright, thank you for watching the stream and see you tomorrow. Thank you for all the donations, by the way, to the people donated. Appreciate it very much. And yeah, gonna start working on the next 2 videos, and that's pretty much it.